Now in this video, let's talk about enthalpy. Now enthalpy of a substance is denoted by H, and mathematically enthalpy is written as H is equal to U plus P into V. Now this is basically an intensive property of the system. So H is an intensive property, okay, where U is the internal energy, P is the pressure and V is the volume. So being an intensive property, the units of enthalpy would be kilojoule per kg. Okay, so this is a point worth noting down. Now, if you look at this expression, dq is equal to du plus pdv. Now if I talk about a constant volume process, okay, now in a constant volume process we know that pdv is 0. So internal energy is nothing but the heat transfer of the system, isn't it? Now similarly we can now talk about the constant pressure process also, because this comes from a constant volume process. So now let's rewrite the expression of the first law of thermodynamics, that is dq is equal to du plus p dv. Alright, now let us say that the process is a constant pressure process. So for a constant pressure process, alright, we'll be interested in this term. So this term, that is pdv, this would become d into pv. Okay, so if I rewrite this expression again, I would get the heat exchange at constant pressure is equal to du plus dpv. So this is something that we get. Now let's work on this further. Let's take the d as common value. So you will get d of u plus pv. Now if you go back to the top of the screen, the value of H was U plus PV, and now let's go back to the thing that we were working on. So U plus PV is nothing but H. So this is enthalpy. So I can write down that dq, or the heat exchange at constant pressure, it is nothing but the change in enthalpy. Okay, so this is what this relation tells us mathematically, and in words we can say that heat transferred, let me write it down, the heat transferred at constant pressure, increases the enthalpy of the system, Alright, now what happens when you transfer heat at constant volume? It increases the internal energy of the system. Alright, so this is something worth noting down and worth remembering. Alright, so heat transferred at constant pressure increases the enthalpy of the system. So to summarize it, let me write down the two expressions. So dq at constant volume, it increases the internal energy, and the dq at constant pressure, it increases the enthalpy of the system. So this is something worth remembering. Now if you talk about the case of an ideal gas, so for an ideal gas, right, the value of enthalpy, it becomes U plus R into T. Alright, so this is the case for an ideal gas. Now, the internal energy of an ideal gas, it depends only on temperature. That is, it is just a function of temperature. Okay, so this means that the enthalpy of an ideal gas will also be a function of temperature only. Alright, so this is something that you should always remember. So internal energy and the enthalpy of an ideal gas are nothing but the functions of temperature. So this is all that you need to understand in this particular video on enthalpy. And you should always remember that enthalpy increase is nothing but the heat transferred at constant pressure, and internal energy increase is nothing but the heat transferred at constant volume. So this was all in this video. In the next video, we talk about the perpetual motion machine of first kind.